In this part, we'll look into some examples of good and bad data visualizations. And we'll start with the bad ones. So what is wrong with this picture? Basically, it shows, velocity of the ball, I suppose, in the American baseball. And in 2012, the value is 77.3. In 2013, the value is 75.3. That looks like a very big difference in this bar chart, but actually these two numbers aren't that different. So basically what the problem is here is that the 0 is not included in the graphic. So if you would zoom out and include the 0, then this difference would seem much, much smaller. A second example, this is from a tweet by Donald Trump in 2016, showing the average annual economic growth during the years that Barack Obama was the president. And again, there's quite a few issues with this plot. One of them is, if you look at this value, 1.4, and if you follow that line, this is not 1.4. Right? That's one issue. The second issue is, well, that's quite clear. This is 58 years. This is 7 years. So there's maybe a lot of things going on here that are not shown. So imagine that, for example, the economic growth on average during Obama's presidency may be lower than the average in those 58 years, but maybe that it was really low until, I don't know, 1990, then dropped very, very low, and actually it went up again during Obama's presidency. That's just 3 planes flying over, so sorry for the noise. Another thing that is not clear, so again, that's context, right? So what is the context of the years before 2009? That's not clear here. Everything's just aggregated into one big lump of 3.5%, so we don't know if actually it goes down and then goes up again. Another thing that's not clear is the context worldwide. So what if, well, even if this is correct, what if the annual economic growth in Europe and in Asia would be much smaller than this, than 1.4%? Again, then this is really, really good, right? So both geographical as in time, there's no context. Well, I said that 1.4, this is not 1.4, but actually that's not the only problem. The problem is as well that there's no 0.5, so it jumps from 0 to 1, then 1.5 to, that's always 0.5, but there's a jump of 1 in the bottom. Also, these things are not aligned, so this is 1, this is 1.5, 2, 2.5, 3, this is 3.5, and this is 4. Again, some planes flying over. Yeah, so not the best graphic. Next question, so yeah, what's wrong here? Again, it's quite clear, it's too many different categories. We'll see later that actually color is really good for categories, but up to 10, maximum 12 colors you can use, otherwise it's not clear what is what, right? Or you might have to go cycling through the same colors again. So in this case, so this bacterium is the same color as this one. This is a tricky one. The percent of total US population by race and ethnicity between 1960 and 2060, well, that's a prediction, obviously, unless you're watching this after 2060, but still it's a prediction. Several issues with the plot, right? One very clear one to start with is like, well, the color use is not logical. So black is blue, white is red, Hispanic is green. So what are those colors? They don't make sense. Well, you have to really think about, okay, what is the blue one, and then search what it is. Another issue is that it looks like there's Asian people until 1970, and then there's no Asian people until 2058 or something, right? So purple here is gone. And there's no other ethnicity whatsoever except for those 4. They only appear at the very end of the timeline, right? So what's going on here? Basically, what we think might have happened is that this is just an area chart. So imagine not having the shape of the US, but having a regular square. In that square, you actually, you show the different proportions as they change over time. So which means that this would all be green. So this area would be green. This would just be filled in with blue. And this purple actually would extend all the way to this, and there would be orange on top as well, right? So you would actually see everything. And then it looks like they just stenciled out the shape of the US. Not the best visual, right? So the next one we're looking at this is a statistical graph, right? A bar chart with error bars. Yes, there is no access legend here. That could be improved, but there's something more important that's going wrong here as well, which is something that you will not realize if you didn't follow this course, and if you don't look at things from a visual perspective. So basically, what we see here, this could mean anything. For example, so this is the same thing. So yeah, we might have 2 different data sets that are symmetric, okay, but there may be outliers that we do not see. We don't see the outliers. We might have bimodal data. We don't see that here. Or we have an unequal number of elements. That's something we also do not see. So what is underneath this in region 2? Is that bimodal? We have no idea, right? So in respect to this type of plots, we also talk about the zone of irrelevance and zone of invisibility. The zone of invisibility means there's data points, the actual data points that are not represented in the plot, right? So this area here, there's no visual clue there, and still there's data. On the other hand, there's also this zone of irrelevance. So there's no data here, but at the same time, there's a big visual signal here, right? So it really looks like that there's something really strong here at the bottom, but actually there's nothing there, right? So always plot the actual data. So those were some bad examples, but we'll look at some good ones as well, and some old ones. This is actually a really old one from the 1280s. It's the Hereford map. So it's a map of the Middle Ages. It's about 1.5 meters by 1.5 meters. It's on a veal skin, right? And as any good map, it has Jerusalem in the middle. Jerusalem is here. Oh, sorry, that's Jerusalem. This is the Mediterranean, and Eden is at the top, right? So Eden, which is Eden is at the top. That's one thing. The other thing is that East is at the top, right? So this is East, this is West. So we have North and South on this side. So the Orient is at the top, and that's actually where the word orientation has to do with this as well. So orientation, that the maps are actually pointing towards the East, right, towards Eden. Well, the fact that Eden is at the top here and the UK is here at the bottom, I don't know what that says about the UK, but you draw your conclusions, right? Another example here is by William Farr. He's a quite important person in data visualization as well, looking at cases of cholera in England in the, let me remove, in the 1800s. And but actually the next plot is linked to that as well, right? So this is a plot by John Snow looking at cholera. And the problem is that at that point in time, they did not know yet what caused cholera. So would it have something to do with miasmas that ooze from someone, or is it in the air? They had no idea. So what John Snow did is he did the actual first epidemiological research, in the sense that he looked at, let me zoom in. Can I zoom in? Give me a sec. Yep. So he found that there were a lot of people getting ill around Broad Street here in the UK, in London. So we started looking into that and collecting data on houses and how many people died in that house. So if we zoom in a lot here, right? So we see here 1, 2, 3 people died in this house. 1, 2, 3 people died here. 4 people died here. 1 person died here. 2 people died here. A lot of people died there, right? So not only that, so basically this is like a bar chart, basically, right, of how many people died. He also plotted the locations of water pumps on this map. So there's a water pump over here, there's a water pump over there, there's one over there, there's one here in the middle, there's one over there, and so on. All those water pumps. And so actually, so Jon Snow saw that most of the people who died were around this water pump. So he basically then came up with the hypothesis, well, maybe it has to do with this water pump, right? So that's what visualization does. Visualization, we help, given an open question like what's going on in this case, what's going on, visualization helps build hypotheses. So what they did, actually they removed the handle of the pump, and then that actually was one of the first steps in actually stopping that cholera outbreak and finding out it was water. That was one thing, and then stopping the outbreak of cholera halfway the 19th century. So taking away that pump, the handle of the pump. We also see that there's no people dying here, but that was a brewery, so people would drink the beer. There's also a workhouse here with a lot of people living there, but still not that many people dying compared to the number of people that live there. But they had their own water supply as well, so they mostly drank from their own water supply, not from this pump. You'll also see there's some people, someone who died over here, even though there's a pump really close by. But Jon Snow did a really good job and actually started interviewing a lot of people. And apparently they did get their water sometimes from the pump over here in the middle. Okay. And this is that location in London. So this is Broad Street, or is it, either it's now a different name, Broadwick Street, or it's on the corner. So the pub Jon Snow, and this is not the actual pump, but it's like a representation of the pump in the day. A final example that I show here is on shipping traffic near the port of Rotterdam and Amsterdam. And it's not completely in my screen anymore. Why is it not in my screen? That's interesting. Give me a second. Let's try and get that in the screen again. Nope, it doesn't work. I can make it smaller. Never mind, I shouldn't have done that. Let's go back. So basically, so this is maritime traffic around the port of Rotterdam. And we see that in if the weather is nice, if the weather is good, then we have really clear shipping lanes and anchor zones where ships are actually, if they're anchored, they really stay at one location. But if it's a stormy day, then basically those shipping lanes become much more erratic, and the anchor zone becomes much more disordered and disorganized as well.